started working on that 5 or 6 years ago or something like that.
Yeah.
So it's a little bit weird because you're going to learn Revit here, kind of out of the box, and every company's going to have their own different ways of doing things. Revit's kind of a weird open program. You can do a lot. You can do one thing 12 different ways. So you'll understand the basics here, but once you get into another company, there's going to be some nuances and stuff. So, anyways.
All right. Did you introduce yourself?
Yeah,
Or do I
I'll
need to?
do
Okay.
Big brainer from shop. I've been on the shop for 10 years, like I said, focusing mainly on data center stuff, working with Guyver and Sean T-Wall directly. You'll probably see quite a bit of me this year. You're going to be probably seeing a little bit of Guy and Phil, but I'll probably be coming to answer questions and stuff. And I do have an AutoCAD Revit background, so I should be able to answer some of those technical questions. Some of the Revit ones maybe get a little bit over my head, so I'll bring in some of our Revit support back at the office if I can't answer questions. I'll just take some notes and get back to chat to make sure I follow up on those questions. So I don't know. I guess we're probably going to go over the scope of work document.
Yeah. Here's what I have for you, Nick. I don't know. I have the Revit open. I can if you want. What I done best, I can maneuver while you talk.
Yeah.
Or certain things, and I do have all the CAD stuff open.
Okay.
So, and also all the document they're looking at here is also open.
Probably fly through.
Yeah. So if you want me, I can maneuver while you. This is this one right here.
Yeah, that's the one I'm going to probably talk about. I don't know if you want to talk about that other one.
I did talk about the other one. The only thing I thought is if you can fly through the schedule,
sure. Yeah.
and just the document that you have.
Okay.
And the rest I already did.
Okay.
And while you talk, maybe I can switch it to Revit to show them where they are. You want me to drive, or you want to drive it while you talk?
I don't care. You can drive.
Okay, so I'll sit here then, and I can drive.
Well, this project is going to be a medical product manufacturing plant, so it's going to be a little different than the last project. A little more industrial. It's going to be a plant, so you're going to have all sorts of different, like loading docks, and there's going to be some office spaces, private offices, obviously restrooms. There's going to be a data center component along with the UPS room. There's also a hazardous material area that kind of has a separate section. The code's kind of got to deal with that a little bit differently. A generator room. There's going to be a telephone and data room, mechanical, electrical rooms. So that's kind of the overview of the first floor. The second floor is going to include some research lab area and employee break rooms. First floor is about 1,600 square feet. The second floor is 8,000 square feet. So that's close. This area over here is going to be the research lab area. These are lab desks. There's also some environmental chambers that you can kind of heat up and get humid and things like that and test your products inside of this big environmental chamber. Yep, that guy.
So is it mostly going to be the lab, like an office area lab on the first floor, and the offices on the second floor?
No, the offices are on the first floor. So let's jump to the first floor and kind of go room by room. So first floor, we've got our front door here, kind of our lobby area, a couple front offices. There's an elevator also involved. This area here is going to be kind of your open office area that kind of has, cubicles and stuff like that. It's partition type furniture that you feed with one power feed, and it gets electrified through the spine. There's a data center component here and a UPS room. That UPS room, oh crap, this actually is a touchscreen, isn't it? Careful. This UPS room actually is expanded in the Revit model.
Okay.
So it's a little bigger because we made a change this year to go to like a 2N UPS distribution system, and we can talk about that. There's going to be kind of a bathroom area here-ish, some stairs. So that's kind of the bathroom area. Our data and telephone room here. Our mechanical room that's going to be housing our chiller and boiler. Electrical space right here that's going to have our generator and paralleling equipment and service entrance. That's our hazardous equipment room. This is going to be where you've got that separate section in the code dealing with hazardous equipment, hazardous materials. Got a loading dock, and then this manufacturing room, which is really where all the business is happening. They're, you know, building stuff in there, medical things. It's kind of this mystery cloud. That's kind of the first floor. The second floor is, this is the lab space. So if you notice, this area here is, there's nothing there. So that lab space is, it's actually 2 stories. It's an open kind of warehouse area, bigger area, you know, 2 stories open. This kind of break room here. We've got a kind of a conference room down here, lab space, and then mechanical room, penthouse area. So that's kind of the gist of the floor plan. From what I understand, you're going to be doing all this in Revit, though, right?
Yep,
I mean, all the
design.
design things. Yeah, here's the building site plan. We're going to be doing some site lighting. Going to be some lighting protection. There's going to be some building lighting. Be a handful of things.
Yes.
Future expansion.
So this is the building, and right next to it, we're gonna be paying attention to the future expansion. So Revit does not show the future expansion. All these files, guys, you have in your team folder. You can look at the CAD as well as the Revit. The reason why I open CAD, because CAD is more organized at this point than Revit.
Are we gonna be doing anything with the future expansion though? Aside from making it like 50% more.
No, I don't believe so. You're just going to be sizing like the service for a little bit more, you know, 15% bigger. A lot of the times with future expansions, you kind of talk about that really early on when you're just drawing boxes of the outside of the building. And sometimes, you know, you want to put, maybe you make design decisions to get your electrical room over where that expansion line is going to be. So there's less like feeder links from, you know, your electrical room to the new future space or something like that. You know, any kind of little nuancy, money-saving type things that you can make that decision if you're planning on expanding, even if they don't expand. You know, maybe it makes sense to shift some stuff around or whatever.
Just make it accessible and the service big enough, but then it's just kind of hypothetical.
Yep, correct. A lot of companies do that. They leave the option open, you know. And if you plan for it and maybe even grade that space while you're grading, you're going to save some money in the future. You know, and a lot of the times the last big data center that had an expansion, they just did a crap ton of conduits, you know, spare conduits that are capped off into here. So all that stuff's already underground. They just have to excavate it and continue it, you know, later on. So it's always kind of good to think about future. Some owners just don't even want to fool with it. They know that their building's not going to get big enough. They know that they're not going to need more. But it's always kind of a good thing because it does cost something, even though it's not there. It's still going to cost something. Maybe extra grading or extra conduits. So that's kind of the overview. Really, there's going to be electrical distribution, emergency power system, lighting, normal power, and communication systems included. A couple assumptions. There's the owner is going to be providing the telephone system, so you don't really have to design the equipment and the cabling and that will shoot match, but you will have to do rough-in boxes. So you'll be showing, you know, data receptacles or phone receptacles, but you won't be designing the system. You'll just show that junction box there. I'm assuming that's coming from you, Jack, where the
They throw just the samples in there. It's nice to throw these data for sample, so they know how to lay them out at least. But building the system together is going to be a special thing.
Yeah, but that kind of gets into like servers and patch panels and racks of stuff. That's kind of like network architecture that even at Mashab we don't really get into. So
we have a low voltage group that does.
We do, and they will, but a lot of times owners end up either doing it themselves or they'll bring in like, you know, somebody else to help out, like Encompass or a different company that only focuses on it. Yep. So some of the electrical service information. I'm just going to fly through this document quickly. Have you guys read this a little bit? Kind of looked at it.
We were shut down yesterday,
Yeah.
as you know, so today's the
My
first
car
day.
didn't start yesterday.
Did it? Yeah. Oh boy. So you guys have it. You have that document with you. So I just walked you through everything except that document. I flew through it a little bit.
Okay, cool. Well, we'll do it quick. The main service is 480 volts coming in. It's going to be UL 1558, which is a little bit of a chunkier piece of switchgear. real well built, usually compartmentalized. The breakers are going to be draw-out circuit breakers, which are the fancy, best of the best type breakers that can quickly and easily get replaced as long as the cradle is still okay. You can pretty much just draw that breaker out and plug a new one in. They're almost plug type breakers. They're pretty cool, but they're really expensive. We talked about some using Schneider Electric, GE, or Cutler hammer, or Cutler hammer. Service size and generator are going to have 15% growth included into them. For the emergency power, the generator is going to be supporting 100% of the building, so you don't have to worry about sizing a smaller generator for just life safety. It's going to be the whole building, which is sometimes typical. It's definitely typical in data centers and these types of facilities that the whole building is important. Like an office space, maybe a little less. You save some money by sizing the generator smaller and just do life safety ones. There's going to be paralleling equipment, and it's going to allow for closed transition transfer to emergency generator, which means when you go from utility to generator, you're not going to see a power blip. It's going to be all seamless. You turn the generator on, sync the two sources, move the load over the generator without a power out. We are going to be providing separate automatic transfer switches for the life safety panel board. Even though the generator is going to be feeding the entire building, we need to separate the building and the exit egress life safety stuff separate. There's some coordination things that we need to do different, and that's the reason why we separate them. We'll be having some surge protection devices. I should update that. They don't call it transient voltage surge suppression anymore, TVSS. It's SPD now, surge protection device. Just industry jargon. Design criteria for power, we kind of talk about where the owner thinks that they need power. Most of that's pretty self-explanatory. Power distribution, there's going to be some floor boxes in certain areas. There's going to be furniture systems. This was one thing we tweaked from last year, that we're going to be doing 4 circuits to the furniture systems. This is sometimes referred to as 2+2. This is down there. 2 hots, 1 neutral on the ground, and then 2 hots, 1 neutral on the ground. Both of those will be going to the spine. We'll be using 2 UPSs and 2 power distribution units in a 2N configuration, so system plus system. And that kind of talks about our UPS system. One side of the UPS system is sized to handle the entire load of the building. And then once you get that size, you just double it, and then you power everything with 2 cords. So you can lose either side of anything. If this side completely goes down, you're still up and running out on the raised floor. And that's pretty typical in a lot of data centers. There's all sorts of different configurations that data centers do. Some do a 2N, some do tri-redundant, some do catcher. There's all sorts of different ideas and electrical architecture to feed data centers, but this is kind of the traditional, expensive, for sure way to do it. The UPS is going to include 15 minutes of battery. Well, I don't know how far we want to get into what a UPS is. Do you guys know what a UPS is? It basically is charging a bank of batteries. It's taking AC power to DC power. DC power is going to the batteries to charge the batteries, and then DC power back to AC power out to the load. And when you lose power in, the batteries feed that DC middle part, and that DC middle part just feeds through the rectifier and out to feed the load with AC. So if you lose power, you've got 15 minutes of clean, good power until the batteries die, and then your stuff downstream goes off. So the idea of that is when you lose power, your generator is going to start. So generator starts, and that takes, I don't know, depends on the situation, but 10 seconds. Unless they're parallel multiple generators, it might take a minute or 2. And that time there, you're going to not have power. Your utility's out, your generators are starting. So that time where we don't have power is dealt with the batteries. The batteries are feeding the load. Once your generator's up, your batteries get charged again because now you have a source of power. So that's kind of what UPSs are for, is to kind of bridge that gap between utility failure and generator feeding to kind of get you that.
You know what's on the stick, right? what's on the stake is billions of dollars.
Yeah, sure.
That's what's on the stake. That's what we're doing.
Lots of data centers. I mean, U.S. Bank, we were quoted $2 million in minutes that they would lose if they were out of power in one of the facilities we worked on. So it's serious money, and that's why these guys don't even bat an eye. You know, size of one system and just literally double. I mean, it's, you know, $10 million for this one system. And I'm like, ah, let's do it then. So we're talking about a lot of cash here.
So the idea is redundancy. If one system is to fail, the other system will take over,
Yeah.
and you're going to see a flip.
That's the idea.
Sorry to jump in.
No, absolutely. So yes, we've got 15 minutes of battery, and that number kind of fluctuates. Some people, depending on their workflow, you know, you might only need 1 minute. Some people actually ask for like 60 seconds. You can get into different types of, well, I'm kind of going on a tangent here, but you don't need to use batteries either. There's different technologies you can use to store energy and to things like flywheels and fuel cells, and there's all sorts of crazy ideas out there. But batteries are traditional. Everybody knows them. They're comfortable with them. There's a huge long track record of them being used in this situation. So a lot of people, we end up with batteries 98% of the time. But sometimes there's other technologies out there that fit needs. We need to size the UPS and the PDUs to support 5 kW per rack upload. So when we talk about per rack, let's maybe jump to the data center. Can we jump into the Revit model floor plan? Because this one's a little bit weird. We modified this for the load. So if you go to floor plan power, so we kind of have a little more traditional 2x4, 2 foot by 4 foot rack, where in the other one they were 2x2 racks.
Nice.
So this rack is housed with computers. Not all that far away from what's sitting in front of you. They're usually considered more like a blade server. That, you know, the computer is called a server, and it's thinner. It's usually 2 foot by 4 foot, and it slides in there, bolts into the rack, and usually has 2 power plugs coming out of it. So there's 2 of them which fit with our 2N distribution. So one plug plugs into UPS 1, the other one plugs into UPS 2. So that kind of keeps our redundancy. And those 2 plugs are connected to a shared DC bus inside of the computer. So just like this computer, it's got it's got your power brick, right? That power brick's taking AC, turning it into DC power. So you have a DC bus inside of your computer, where on the servers there's just 2 of those. They're connected to the same bus though. So when you lose power on one, this one just continues to feed it. Typically, if you've got 2 power sources, you know, they're splitting power evenly. But when this one goes away, this one just takes care of it. So it's almost like a transfer switch, but it's not actually doing anything. It's just 2 amps, 2 amps, 0 amps, 4 amps.
It's always explained to me, Nick, is that having 2 9-volt batteries in parallel, and you're feeding a lot, right? Now, if you take one of them, nothing will happen. 2 volt, if you take 2 9-volt batteries, put them in parallel, take the positive side together, negative together, and put it on a light that can handle 9-volt batteries. If you take 1 9-volt of them out of business, the other battery will supply more.
Yeah, it just supplies more. It won't affect the load or anything. It's just going to be more taxing on that second half. And that's why you size both sides of your UPS system full load, so it can handle it. In normal situations, your 2N system is going to be handling, 45 or 50% of the load at any given time until one fails, and then it fails over to 100%. So that's kind of the idea of the UPS, and batteries need 5 kW per rack, and I think there's 40 racks that we show. So we'll have to kind of come up with a standard UPS size and a standard PDU size to accommodate that.
These 40 and multiply them, because you're going to be doing load count this week. You're going to take these 40 squares or rectangles, multiply them by 5K. That will get you the size, the KW size for that, just for the computer.
Yep, and then you'll kind of compare that to standard UPS sizes and standard PDU sizes and figure out where you end up. At each rack, we're we're going to be providing two 208 volt 30 amp feeds to each server cabinet. There's going to be a plug. They're usually twist locks. I mean, you've got your regular plugs that are just straight blade. They plug in, and then they also make a locking receptacle that plugs in and then twists. So once it twists, you put your foot on the desk and it won't come out. So those are kind of just there for these things you can just pull these out. It's a little bit more secure when they're locked in. Because the last thing you want to do is spend $20 million on a UPS system for redundancy and have somebody just unplug it out of the wall. Seems kind of stupid. So there's going to be some twist lock receptacles. There's going to be 2 at each server cabinet, and each one is going to be to UPS A and one is going to be to UPS B, and just 2 plugs from the computer will plug into each one of those. It'll be a nice stream all the way down.
So your server is powered with 208.
Yep.
Not 120 like your computer. You bring in 2 hots to your computer.
Yep. So those let's see, whips from the PDU mount receptacles on the strip above the server cabinet. There's going to be a vertical plug strip within each cabinet also. So those 2 receptacles that are above or under the floor, depending on the situation, those things, because we've got plug strips that are basically plugging into those, and it's not that much far away from a plug strip like this. They're a little bit fancier, sometimes they're metered, but they're vertical and like 42 RU. They're 6 feet tall, and they just mount to the side of the rack. And that's where your server is going to plug into. There's going to be probably, I don't know, anywhere from 10 to 30 plugs on each plug strip, and the stuff that's in the rack plugs into that. So that's the vertical plug strip of each cabinet. That's pretty close to our data center area. It's going to be handfuls of different locations of different spots where we're going to be doing bus duct, feeding bus duct with manufacturer equipment. It's going to be plug-in type bus duct. You can get all sorts of different types of bus duct, but plug-in seems to work the best. There's a hazardous material room that's Class 1, Division 1. We're going to need to focus on the section of the code that's talking about explosion-proof fixtures and sealed light switches and sealed light fixtures and things like that. There's a handful of things we got to do to keep that room safe. We're going to be providing wire mold 4000 series, which is a big wide chunk of wire mold. Well, it's actually similar to the stuff that's along the bottom of the green board there. They're pretty modifiable at each lab bench. Receptacles 3 foot on center and some low voltage. There's going to be a low voltage section also. So it'll be on each side of that lab bench there. Provide power and voice beta service poles at the ends of each lab bench to provide service, to provide power and telephone data cabling. So sometimes owners will, yeah, I mean, this is a power pole. A lot of architects will laugh you out of the room if you bring this up. It's not very visually appealing. But so in your offices or something, you typically wouldn't use power poles. But in this case, it's a lab. These are probably cheaper than drill. The other option is to drill into the floor and have a floor box or something. And in this case, we've got access to the ceiling, so we could maybe do it, but it's more expensive and probably more pain to install. So power poles is what we're going with in this case, but maybe not in other facilities. Power connections to the environmental chambers. There's going to be some HVAC panels on the first and second floor. There's going to be an owner equipment list, assuming you got that, Jen. So this guy is going to talk about kind of each piece of equipment the owner is going to bring in. A lot of the times in labs this happens. There's tons of coordination on, getting cut sheets of this. Usually it's not in this organized of a fashion. The owner comes in with all sorts of things in their brain, and they've got cut sheets of stuff, and some of the stuff's from Europe, so you're dealing with 50 hertz sometimes, and you got to do transformering and all sorts of crazy stuff. Most of the time, especially in labs. We're currently doing a 3M lab and dealing with a lot of that stuff. We did some Boston Scientific stuff, and it was a lot of that is just crazy stuff that we had to go, okay, how do we make this usable with our power source? So you're lucky for getting this because this is pretty nice. But you'll have a number of machines, voltage, phase, amperage, and that'll help you kind of figure out how big the disconnects off the bus duct and stuff will be. Design criteria for mechanical equipment. We're going to be providing new mechanical equipment, starters, disconnects, overcurrent protection, conduit, conductors. And there's going to be a attach list for that guy.
Mechanical equipment right here.
So we've kind of got some voltage, phase, horsepower, kVA, different types of control, whether or not we have a VFD or a full voltage non-reversible starter, kind of who's dealing with what, and different notes. A lot of the times we'll be getting cut sheets from our mechanical counterparts because we have a mechanical and electrical department. So the mechanical people are going to be designing the mechanical side. They're going to come up with what they think they need, give us cut sheets, and we'll kind of develop this. So there's a little more coordination in the real world when it comes to this, but in this case, this is how we're going to do it. The next one, I guess, would be lighting. This year, unrealistic or not, we've decided to do 100% LEDs. So in the real world, that might not make tons of sense because LEDs are maybe debatably not quite there yet. They're really expensive. Some of like the light distribution can get a little funky. They're real bright and kind of harsh, but they're coming and they're being used in quite a few spots already. So you look at all the parking lot, all the new parking lots, all the new road lights, they're all LED. So it's coming. You can do lots of stuff with, like high bays and like high intensity output and all sorts of stuff. So you're gonna have to kind of dig through the lighting manufacturer catalogs to come up with some of this stuff, but should be kind of fun.
What we did with Davis and Associates, they want to do is, because we deal with them, they will give you the IES file for all these lighting fixtures because it's really hard. So you will have the IES for every single fixture here, so you can run your visual as well as a cut sheet. So it's really easier than what we do in a commercial project team. But that doesn't mean you can't dig and find it. So it's already there. But we made it easier by giving you an IES file and a cut sheet about each one of these fixtures.
And Mashad, we have a lighting specific group. So each individual designer can put together lighting plans, but if you've got any kind of like artistic questions or any kind of, maybe they start out at the beginning with some sort of architectural vision of how they want the lighting to look and feel, they'll maybe come up with this list for you and pick some of the fixtures and some of the alternate fixtures, and you'll just go through and plot the stuff down and circuit it and do the photometrics and stuff like that. We'll have different types of controls, switching and dimming and occupancy sensors and things like that.
We do not have a lighting control panel in this project like we did in the past. When you see a ceiling mounted occupancy sensor, that's a standalone system. There is no lighting control panel. So just be aware.
So on the next page, we've got a lighting protection system. Most new, especially new buildings, will be providing this. You're going to have some lightning rods on the top connected with all sorts of stranded conductor up on top, coming down leads, some ground rods in the ground, and that master label is kind of like, it's basically like the I don't even know what the name of it's like the National Lightning Association or something comes out and gives your system a master label, which is basically, okay, you've installed it, an inspector's going to come out and go, yep, that looks good. You get your master label.
But it means a lot for the insurance company.
It does. Insurance really cares about it.
So that's,
and lighting protections are good because it's just a bit of an insurance policy when it comes to lighting strikes, and you never know where lighting's going to strike, how it's going to get into your system. We've seen it do all sorts of crazy stuff, like striking a a light pole and getting into your electrical system and blowing shit up inside. So I mean, it's something that's definitely good to have. Some people opt out because it can get expensive, but it's something we definitely recommend. There's gonna be a paging system. That's a little bit straightforward. Fire alarm system. It's pretty much a complete fire alarm system. Yeah, there will be some pre-action sprinkler systems in the computer room. So a lot of times you don't really want to put, so computers and water don't really go very well. I mean, if you drop your laptop in a bucket of water, you'd be struggling, right? So times that by, I don't know, 10,000 laptops that are in a server cabinet, and the laptop is, instead of $500, it's, I don't know, $3,000. There's a lot of money packed into that computer room, and to put a wet pipe sprinkler system in it seems kind of crazy. Even if you did have a fire, you don't want to douse your whole entire computer room with water. So they get around that by there's all sorts of different kinds of fire suppression techniques that allow you to not have water in your data center. The further away you get from water, the more expensive it gets. The cheapest is just put a pipe in there, and if a little sprinkler head melts, just dump a bunch of water on it. That's the cheapest way to do it. You can also do something called pre-action, which is kind of like a dry pipe system that will it'll basically fill your pipes with air, and it's usually like a two. Is this one talking about a two-stage? Yeah. So a smoke detector must go off, and you must have melted a head or something. It's got to be 2 stages, so it's got to make damn sure before. So your head usually melts first, which lets out all the air. So you've lost pressure in your pipe now. And then if a smoke detector goes off, it says there's for sure a fire. A valve opens and dumps a bunch of water everywhere. So it's 2-stage. There's a little bit more of a. So if somebody's walking with a ladder and knocks a head off, it just lets air out. It won't let water out, and then you've got to get that smoke detector to pick something up to make sure that it's a fire before water comes. There's also some other things that we do that are kind of more like an agent that kind of fills the room up that will kind of put the fire out without water at all.
Like a fire, or even like they have one that just pull air out of the room.
Nah, that's the old way to do it. There was I don't remember what they used to call it.
Well, they have at the airport when they have like fire in an airplane, they have the agent,
Sure.
chemical agent that will flood
And that's a foam, I think. I've seen that.
Yeah.
The ones that we usually use are FM200 or Sapphire, I think is another name brand. But it's an inert gas that you can't see that will flood the room. The room has to be sealed up. You can't have any kind of air gaps. And it doesn't take. I don't exactly know what it does, but it doesn't take oxygen out of the air because some people died. They put some fire suppression systems in like generator enclosures, and there'd be a fire. The thing went off, took all the oxygen out, the guy couldn't get out, died in a freaking generator enclosure. So this stuff's good. It's fine to breathe. It's probably not great, but it basically fills the room up with this gas. You deplete your tanks that are probably $50,000 to fill again, but it puts a fire out without water, which is the important part. And a lot of places they buy that way before they even think about getting water in that room because it's just kind of scary. Even with a pre-action system, it's kind of like that. I don't know, maybe we want to do FM200, but this is definitely cheaper than FM200, but it's a little bit more expensive than just straight water. So you will have some manual pull stations, smoke detectors. Kind of talk about the layout of that. Technology raceway systems. Going to be having conduit. There's going to be some ladder tray. Technology raceway as noted on the owner markup drawing. So Chad, I'm sure will help you out on where he thinks the raceway needs to go. So that's that document. I think there was one more attachment that had something to do with the security system. There's also going to be a security system. We're going to have a main security panel, some door contacts, motion detectors, glass break, audible alarms, and main staff keypad. And
Yeah,
then,
it just pull, these are a little bit extra for fuel switches
Oh,
and
sure.
camera switches and one strobe outside
yep,
Siamese
Siamese connection, yeah.
because it wasn't in the first one.
Sure. So that's kind of the overview of the project. It, yeah, it's kind of a little bit different than your last one. And then I guess schedule-wise, let's see that week 1 is well, that's right now. We've got week 2 is going to be low voltage contractors. They're going to come in and talk about fire alarm, clocks, and paging systems. The 16th, I'll be in here probably, helping you out with any kind of questions we got.
Any given
16th,
questions about the good for something like a little team and things like that? Think about them considered.
I'm not exactly sure what those guys. What's the topic about? I mean, what are they coming in
if
and
you
do?
look at, like, for example, in week 2, January 13 through 17, we will be working on low voltage system clocks, security,
Oh,
fire
sure.
alarm.
Yeah.
So we'll bring a low voltage expert to talk about the same topics.
Yeah.
Like we did in the commercial project, so it will help you with the layout of your forms and strobes for smoke detector for fire alarm system as well as speakers for the paging system. So extra help for you, expert in the particular field. So
You'll probably have some good topics. You'll be in the middle of it. You'll
yeah,
probably be able to.
sometimes they go above your head, but it's like it's just a really nice. But ultimately, the layout, I'll give you the layout. They'll fill the gaps
Yeah.
and what's not.
Yeah.
Just FYI, I think this one here is we're going to Boston Scientific, so it should be in a week.
Oh, okay, that's the 16th there. So yeah, the low voltage contractors will be in on the. Let's see, where were we again?
So low voltage contractors, right?
Oh yeah, sure. So on the 16th, I'll be in here. 121.
For the 16th, we're going to Boston
Oh, you're right.
Scientific.
So I won't be in here. I've always been meaning to get to one of those with the guys.
That'll be great.
Tried to do that. Power distribution speaker on 121, Jerry Stanton from Square D. He's a good guy. He comes into our office once a week. We use him all the time. If I ever come across a question that I don't have an answer to, and I need an answer right away, I call him. He's a good resource. He'll be able to drop tons of knowledge on you when it comes to switchgear, surge protection devices, pretty much anything Square D's got. He can help you out. He's a pretty knowledgeable fellow. Mike Braybeck on Tuesday, 128, Davis and Associates lighting. Also the same thing. If I've got lighting questions, Mike's the guy. He, if our lighting group's out or whatever, the guy knows everything about everything when it comes to lighting. So he's a great resource. The 30th, I'll be in. On the 24th, we got Thompson Lightning, Doug Franklin. I haven't dealt with Doug, but I probably have dealt with his boss. We use Thompson Lighting all the time to help us with our lighting protection design. They do almost all of the lighting protection installations and design in the area. They're a huge company. That's what they do. It's a pretty interesting topic. Just how they see lighting working and how you have different zones of protection and different. It's pretty cool. That's kind of a neat presentation. So the 2-6, I'll probably be in. To be determined. Do we know anything else about the Cummins?
Yeah, to be determined as well.
Okay. So the Cummins plant is a pretty cool tour. Chris Hoagland is the Cummins rep. He's a pretty good guy. Deal with him a lot. And it's pretty cool. You get to actually see the plant, watch them build stuff, and they'll fire up their big old generator plant that backs up the entire facility, and they'll just show you closed transition paralleling and things like that. It's pretty neat. So hopefully we can get a date on that and make that happen because it's something you don't want to miss. And then 13th, I'll be in. Looks like you got 217 off, so that's exciting. 218 is EMI. Michelle Kinville. EMI is kind of a custom electrical equipment builder. you got the big guys like Square D that kind of build the stuff that's in their catalog, and they don't really go outside of their catalog very often, and if they do, it's crazy expensive because moving this big behemoth of a company to like do something custom is difficult. So we go to guys like EMI or States that are smaller and extremely flexible. They'll literally do anything you want in their UL shop. They can build anything and get it UL approved, and so that's always a good little tour. You'll be able to see their factory also. On the 20th, I'll be in. 25th is Allianz. That's going to be an office and a data center tour, so you'll actually kind of get to see a data center. Getting in a raised floor space is pretty neat. You'll hear the humming of hundreds of servers running all at once, and it's pretty cool tour. Let's see, the 27th, 227, I'll be in. 3-4, you'll probably see more of me. I'll probably be doing that SKM Power Tools office tour. We'll kind of break down Power Tools a little bit and kind of give you the hour overview tutorial. As you're working in Power Tools, write down your questions and bring them in. Either that or ask me before this training, but I'm pretty involved with SKM development at Michelle also. I know the nuances, ins and outs, pretty much how to do everything in SKM, so I'm a good resource there. But you'll be in the MCE offices, in boardroom 1, watching the TV. We'll have SKM up and kind of showing you a couple projects that we've done in the past. So that'll be good. 3-6, I'll be in answering questions. 3-18, got Parsons coming in. Talk about estimating. And 3-20 will be project management. I'm assuming Guy probably will make that. If not, you might see me again. And then project presentations, 3-26. So that's kind of the game plan. Got 3 months ready to go.
Less than that, even 11 weeks.
Yeah, sure. So that's close to, I don't know, close to what I got. If for sure, write down your questions. If stuff Chad can't answer, I'll take a swing at it when I come in. If I can't answer them, I'll take them back. What we did last year too was there's a lot of family building questions and things that I couldn't quite answer, especially in a small amount of time. Kurt Gates from our office came in and kind of gave like a rabbit tutorial. He's the dog rabbit guy, and he lives and breathes rabbit every day. So if that's necessary, we can bring him in too and kind of talk a little more Revit specific stuff that is a little over my head.
Any questions for that? So Michelle Fullerton basically adopted this project, which means we use their scope, their narratives. They contacted the speakers for us, and they've done it for the last 60 years. So they're a great resource for you, and they employed many people. Nick is one of the graduates from the students, and then actually, when you go to Michelle Fullerton, you'll find a lot of people who graduated from here. So great resource, great employer too. So you guys are going to see a lot of them here. So
yeah.
I know it's overwhelming when you look at all the stuff, but for a commercial project, it's tough. You have 11 weeks. 11 weeks is a long time. So it'll come together.
Yep. One piece at a time.
Absolutely. So any question for Nick, guys? That's it.
Cool.
Thank you, Nick. I appreciate it. Thanks.
Give you salutation, huh?
Back out on the cold now? Is that the deal?
Yeah, thank you.
All right, thanks guys. I'll see you soon, I'm sure.